Hey, this is Mr. Krenz, and in this video I'm going to introduce to you how to evaluate trigonometric functions. So trigonometric functions is our final unit here in Algebra 2, and their main two uses we have for trigonometric relationships. The first one is going to be when we're dealing with some kind of cyclical relationships. It's where things go in cycles, where things go up and down and they'll kind of go back and repeat each other. The other one, which might be more familiar from geometry, is when we're going to try and relate angles to some other kinds of quantities like side lengths. So from geometry, sorry about that, from geometry you probably remember dealing with right triangles and dealing with SOHCAHTOA there. SOHCAHTOA. Alright, and that was a case in which we related angles to the different sides. So we had x, y, and z, and we had sine, cosine, and tangent. Now these things are all connected, but we're going to take a different approach to interpreting these guys. We're going to focus in Algebra 2 on the cyclical part of this, the cyclical relationship. And so, since that's related to a circle, we're going to look at a circle. Okay. Now, for the circle, we are going to call this guy the unit circle. The reason we call this thing the unit circle is because it has a radius of the unit distance, a radius of 1. If you go from the origin here at the center of the circle out to anywhere, you can see that it has a length of 1. Right. Now, using this circle, what we're going to do is we're going to start all of our angles from right here. And then for positive angles, we're going to measure them going this way. Right. So you can go around the circle and go around it however many times you want to and get to a certain angles. So for example, if we want a 120-degree angle, I would start at the green segment and I would rotate around to get there. And then that would give me this angle. Okay? So there's the angle part of it. And now the question is, what number are we relating to this angle to? There's actually 3. We're going to have sine, cosine, and tangent. So given some angle, the way we find the sine of it is we look at the angle, we look at the end coordinates. Let me choose a different angle to start off with here. So we start, say here, let's look at a 30-degree angle. So it means I measure up to there. There's 30 degrees. Measure that out. And then the numbers we're going to use are these coordinates right here. For the sine of an angle, we look at the y-coordinate. Right? For the cosine of an angle, we look at the x-coordinate. And then for the tangent, we're going to use both the x and the y-coordinates. We'll actually take the y and we're going to divide it by the x-coordinate. So just for example here, if we have a 30-degree angle, the cosine of this would be the x value, which is the square root of 3 over 2. Right? The sine of this value, we look at the y-coordinate, would be a half. And then for the tangent, we have to divide those two numbers. Right? So go through a few more examples to show you how this works. But the thing to keep in mind here is what we're doing is we're starting from that green segment and we're measuring clockwise, or I'm sorry, counterclockwise if it's positive. So we're measuring out this way until we find the angle, and then we'll look at that spot on the unit circle. Right. So start with sine of pi over 6. We look at this is the angle. All right. So we look at the angle, and then the sine tells us we're going to take the y-coordinate of the endpoint of that unit circle. So I go pi over 6, which is right here. So that angle, I look at the y-coordinate, and the y-coordinate is 1/2. So this one must be equal to 1/2. Now just a reminder, pi over 6 and 45 degrees, these are not the same angle. Just a reminder from geometry that we have 2 different ways of measuring angles. Just like we have 2 different ways of measuring distances, you can measure distances in kilometers or mile or feet or centimeters. We can measure angles using radians and degrees. So on the left side of these, you're going to see angles in radians, and on the right side, you'll see the angles in degrees. So for a degrees example, we have the sine of 45 degrees. I go back, I look at the unit circle. Now I need an angle of 45 degrees. So I look and see that's the angle that's right here. So I measure up that far. I look at the coordinates. I'm looking for the sine right now. The sine is the y value, which is square root of 2 divided by 2. Alright. Next are my cosines, and my cosines are my x values. So that's my x, and then 3 pi over 2 is the angle. So I'm going to go find 3 pi over 2 using my unit circle, and then I'll look at the x value. So again, I start from that spot that. I'm going to go 3 pi over 2, which I see down here. So this is going to measure the angle going around this way. So it's kind of a funny looking angle. It's a pretty big one. Alright, there's my point. The coordinates of that point are 0, -1. I need the x value since I'm using cosine, so my answer would be 0. Okay. Now cosine of 210. Again, cosine means take the x coordinate of the angle. We find the circle 210 degrees. So I'll go back. Let's erase those. I'm going to go find 210 degrees, which is right here. Now I need to look and see what are the coordinates of that spot. And if you notice now, the coordinates aren't written, but they're pretty easy to figure out. If you look in the first quadrant, we only have really, we have the numbers 1, 0, a half, √3 over 2, and √2 over 2. So we really only have actually 5 different numbers here. And you can look at this circle and see that it's symmetric in a lot of different ways. Okay? If we go at like the halfway spot here, right, you see that it's not too far out on the x's. It's kind of the middling distance and the middling distance in the y's. Right? We also have a half, which is the lowest distance that's not 0. So you look at like this spot right here, the y value is not 0, but it's the lowest one up. So I know like for right here, that would have a y value of a half. And the tallest is the √3 over 2. All right. So now what I can look at now is when I'm trying to figure out what is the cosine of this angle, I look out here and say, well, that has the farthest distance out on the x's that is not -1. And it's not very far down on the y's. So the coordinates at this point are the farthest out, which would be √3 over 2. And then the smallest amount down, and the smallest of those quantities is a half. Right? And further, since it's going to the left, we know it has to be -x. Since we're going down, it has to be -y. Right? So those would be the coordinates of that angle. Okay? That's -√3 over 2, comma -1/2. I need the x value, which would be -√3 over 2. Let's put a box up here. Alright, tangent of pi over 4. Now tangent means you do y divided by x for the angle that is pi over 4. So I gotta find pi over 4. Let's see, so pi over 4 is the angle that goes from here, that measures up to right there. Okay, I have the y coordinate and the x coordinate. And then you notice they are the same here, so if I do y divided by x, I'll have √2 over 2 divided by √2 over 2. They'd cancel each other out, and you get an answer of 1. For tangent of pi over 2, I need to do y divided by x for the angle of pi over 2. So I go find pi over 2, which is right here. So that's the angle that starts here and measures up. It's also known as a right angle or a 90-degree angle. I look at my values here. That's my y and my x. So I'd do 1 divided by 0. Okay? And hopefully remember at this point that you can never divide by 0. 1 divided by 0 is not 0. Please never say it again. 1 divided by 0 is undefined, because you cannot divide by 0. Okay? Let's go through 6 more examples, and these examples have some twists in them. Alright, sine of 9 pi over 4. Alright, so again, 9 pi over 4 is the angle, and the sine means take the y-coordinate. So I can go back to find 9 pi over 4 on the circle. Alright, and now I know it starts here. Now if I look for 9 pi over 4, 9 pi over 4 isn't on here. Okay? But what I can do is saying that, hey, 9 pi over 4 means taking 9 pi over 4ths. I have 9 of them. So what I can do is say, okay, well, pi over 4 is right here. That's 1 pi over 4, and I need 9 of them. So I look up and say, okay, pi over 4 is this big of an angle. So I can say there's 2 pi over 4s. There's 3 pi over 4s. There's 4 pi over 4s. And I keep going. There's another pi over 4th. There's another one. And then there's another one. And you see my circle splits up into 8 of these guys. So I go 1, 2, 3, 4, 5, 6, 7, 8, and just keep going. 9. Alright, so 9 pi over 4s is the point that's right here. I look at that. I was looking for the sine of it, and the sine would be the y, which is root 2 over 2. Let's do a degree one like that. So 390 degrees is my angle. For the sine, I need the y-coordinate. Let's grab a new one of these. Alright. So for 390 degrees, you look at all the degrees, which are the ones right on the inside. Okay. See that you don't actually see 390 degrees on there. But I know that a full circle, you come around this much, is 360 degrees. Right, now I need another 30 degrees, so I go up there, and I'd have the angle formed with this. You go around a full circle for 360, and then another 30 degrees. So this is my point, and then the y value is 1/2. Let's see, cosine of 10 pi over 3. So cosine of 10 pi over 3 means I have an angle of 10 pi over 3. For cosine, I need the x value of it. So I need to find where is the angle 10 pi over 3, or how do I represent that on the unit circle. So 10 pi over 3. I do not see 10 pi over 3 on here, but I know I have pi thirds, so I think of 10 pi over 3 as 10 pi thirds. Now how big of an angle is pi over 3? Well, it's right here. Okay, so I'm going to divide up the circle into chunks that are that big. I have there on the top half of the circle, I have 3 of them. On the bottom half, I keep dividing the same size there. Okay, so I have 6 of them total. I need 10 of them, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so I had to go around the circle almost twice. End up with a point right here. Okay. And now I have to find the coordinates of that point. So I look at this relative to the coordinates in the first quadrant, and kind of use the symmetries here. Say, okay, it's a lot like this point here, except for instead of going half over, I go a half backwards. So this should be a negative 1/2. And then it's pretty far down, just like this one is pretty far up. So instead of going up root 3 over 2, I go down root 3 over 2. Okay. I wanted the cosine of this. So the cosine of 10 pi over 3 is a negative 1/2. Yes, that was a little tricky. Cosine of negative 45 degrees. So negative 45 degrees is my angle. Cosine means I need to find the x-coordinate of the point that can be represented with that angle. So let me look for negative 45 degrees. Okay. But if you look on the unit circle, we only have positives. Key to remember, with negatives though, it means somehow doing the opposite, somehow going backwards. So with a, look at the number line, we'd have 0 in the middle, and to the right is the positives, to the left is the negatives. Right. With our unit circle, we're measuring counterclockwise for positive, which means to get a negative, we go clockwise. So if I want to find negative 45 degrees on my circle, it's not written here, but I can look at the angle of 45 degrees, which is this guy right here, and then do the exact same thing, the exact same distance, the same size angle, but backwards, which would be this angle. So that is a negative 45 degree angle. So it's represented with this point right here, the point 7 pi over 4. And the coordinates of that point, using the symmetries of the unit circle, and say, well, that's the middle coordinate. So it's very similar to that. The x-coordinates are still going to the right, so it's positive. And the y-coordinates have to be negative in this quadrant, so it would be negative root 2 over 2. Now I wanted the cosine of this angle, so the cosine of it would be the x-coordinates, or root 2 over 2. And on the final two, I have the tangents here. So tangent of negative 5 pi over 3 means that the angle is negative 5 pi over 3. And then for the tangent, is going to mean do y divided by x. So I'm going to find negative 5 pi over 3. Let's see now, 5 pi over 3, it's right here. Okay, so I could think about just doing this angle, but backwards, since I know I need a negative. Right? I think the easier way to do this sometimes, or at least the way I prefer, is to count negative pi over thirds backwards. So if I want negative 5 pi over 3, I could think about that as a negative 5 times pi thirds. Okay. Now pi third is this big of an angle. So I could break my circle up into the thirds. So these things should all be the same size. And then I start right here, and I count backwards. So negative 1, negative 2, negative 3, negative 4, and negative 5. So it's this angle right here, which gives me an endpoint right there. So my x is a half, my y is root 3 over 2, and I need to do y divided by x for the tangent. So I have root 3 over 2 divided by a half. So I have to do some fraction work here. If I could change this into a multiplication if I take the reciprocal of the second fraction. So root 3 over 2 times 2 over 1. Right. And this would make the 2's cancel out. And so my answer is just square root of 3 over 1, or just plain old square root of 3. Alright, the final one, the tangent of negative 390 degrees. The negative 390 degrees is the angle, and then the tangent tells me to do y divided by x. So I need to find how I can represent a negative 390 degree angle on the unit circle. So if you look, I do not see 390 degrees on the circle, but I know that if I go backwards, negative 360, actually, okay, one full circle will give me negative 360. I need another 30 degrees, and since I know that's how big a 30 degree angle is, I can go just that much more to give me negative 30, which means that together, if I go negative 360 and another 30, I get up to a negative 390 degrees. So if I start right here, I swing around this blue, I end up with the same point that's represented with 11 pi over 6, or 330. Now finding the coordinates of that point, it looks a lot, using the symmetries of the unit circle, a lot like this point. The only thing that's different is that the y, instead of being positive, should be negative since I'm going down. So this is root 3 over 2, and then a negative half. For tangents, I need to do y divided by x. So I'm going to have negative half divided by root 3 over 2. Same thing as the one right next to it. To divide fractions, I can take the reciprocal of a second and turn it into multiplication. Here the 2's will cancel out, so I end up with a negative 1 over root 3. Okay. So this is how you evaluate trigonometric functions. What you do is, using the unit circle, you can represent angles in either radians or degrees, and then by looking at a specific angle, so let me find one here. So if you want like a 2 pi over 3, you measure that angle going counterclockwise. And you look at the coordinates of that point, and then based on whether it's either sine, cosine, or tangent, use the coordinates of that point. Okay. Now, I just want to touch back something I said in the very beginning of the video. The reason that we use trigonometric functions in the first place is that so we can model cyclical relationships. Now, we certainly saw how you use the circle for this, but I don't think it's real clear maybe how we use this to model different relationships. Just want to show you an introduction then to the next standard, which would be graphing. Okay. So here in this picture, I have, or in this graph, I have the unit circle set up, and then for this one, I'm going to be looking at the sine graph. So the sine is the y value, and then so as I pull this value around, what we're going to see in blue is the sine graph, y equals sine of x. And so you'll see that this function right here, it always has the same y value as this one. So I'm just increasing the size of the angle. And if you look at the x-axis, it's in terms of the radians. And it always has the same y value. So using the circle and using the way we just defined this, if I pull this back and hit play, right, you can slowly see how it goes in a full circle. And now you start to get this cyclical relationship where it's going to go up and down forever as we continue to go around and around the unit circle. So that's getting a bit into the next standard, but this is how we can use the unit circle to model cyclical relationships.